Okay. So as see, we have discussed many one of these Spark, features. We have used multiple thing on the Spark. The another Spark feature that I'm going to discuss is Spark streaming. So before we talk about Spark streaming, we should know what is streaming.
Continuous flow of data.
Yeah. So, uh, of course, any continuous flow of data, we can say that it's a Spark string basically. And we know that on the core of Spark engine, there are varieties of APIs are integrated, like Spark SQL is there, Spark streaming, okay, that is enable analytical and interactive apps for live and streaming data. Spark MLib is there, graphics, Spark R, now it's been integrated. Okay, and the core engine is providing all the integration with that, right? So when we talk about the Spark streaming, so basically Spark streaming is Spark streaming. Spark streaming is used to stream real-time data from varieties of sources. You know, you can stream the data from varieties of sources. Okay. And what are the varieties of sources? It could be, any Kafka engine. If anyone worked on Kafka as of now, anyone?
Yes, Dipesh.
Yeah.
Uh,
So either you can stream the data from Kafka, you can stream the data from APIs like Twitter API, any sentiment analysis you wanted to do. So Twitter give us the streaming API that you can access it from any stock market API. Stock market APIs can lead you to get you the stream data from any geographical system. You know, from any geographical system, you can take the data for do the live analysis and get the report done. And then on the top of it, because it's using a Spark core engine, it perform the analytics, powerful analytics to help businesses, right? For business use cases that we want. Okay. So basically, Spark streaming is something that will allow you to do kind of a analysis, and then on the top of it, you can do multiple, streaming process. You can do analyze and integrate the multiple streaming process. So Spark streaming is being used for processing real-time streaming data. Okay. So it actually uses for real-time streaming data. Okay, as well as it is useful additional because the Spark core, because as you know that on the Spark core, on the top of it, the other engines are integrated. So it is useful because all the Spark core API functionality we can use that. Again, since Spark streaming enables uh, high throughput, Spark streaming enable high throughput and fault tolerance. So basically, the checkpoint of Spark is a kind of a fault tolerant. Okay, fault tolerant means, let's say, if it's while streaming, if there is any does not happen sequentially, it will do and redirect because streaming processing, the data streamers are getting used on the top of it. So and
Dipesh,
yeah.
yeah, I have one doubt. What is the meaning of high throughput in terms of live data streaming? Can you explain that?
The high throughput of data are like this because see, you are streaming, a very high sequential amount of data is coming in certain time frame. So high throughput, like when you are reading either with Kafka engine or or either you're reading from any APIs. Okay, so what is happening over there? You are reading in certain time interval. Okay, so when you are reading the structured streaming, when you are doing that, so that structured streaming, like periodically it is reading the bunch of huge amount of data over there. Okay, that's why it are taken up as a high throughput of data can be taken on the top of it, because Spark streaming is highly available. Okay, and since it is highly available, it's enable the high throughput amount of data on the top of it. Okay, so that is the meaning of this high through Spark streaming process.
So you are saying high throughput is like Spark streaming can stream large amount of data.
Yeah, I
High
mean,
throughput is large amount of data.
sequential, or you can say that, if I just take the best word for it, I can say, high throughput, in general, you can understand like when the Spark streaming have the capability to educate certain resources. Okay, for that reason, when like when we are reading, there is a low latency, and these kind of thing are also comes under this high throughput process, because it has parallelism process educated on the top of it, resource allocation dynamically happening, so those things comes under that.
Deepesh, this is basically means that it is fast, right?
Yeah, it's a kind of a very fast.
Uh, uh,
It's having ability, Spark streaming have ability to refer large amount of data in real time with minimum latency, achieving uh, for that reason it's achieving high throughput, because uh, you know even when it's achieving high throughput means bunch of big amount of data it's able to take it, it's required to optimize the infrastructure. Okay, so for that reason there are some certain configuration we set up on the top of it. So that is how things happen.
Okay.
so when it comes to streaming, so as we all know that when we move the data or migrate the data or extract the data, so we all say in terms of rows per second. So what is it with respect to streaming? So can we call it as bytes per second, or at what speed the data is, you know, um streamed?
At what speed?
See,
You
when
can,
we uh, so when it comes to data transfer, right? So we say that throughput is high, as in the number of records per second is more. So for streaming, how do you define that? As in, is it bytes per second or this much amount of data? It is like, what is that throughput when it comes to streaming? Hello, did I lose you?
I think there is a connectivity issue from his side. He has dropped off. I think Nikhil has sent something in chat. You want to add something, Nikhil?
Yeah, basically latency means like think we have a system, okay, and we are sending the data to the system. After receiving the data, till what time it will give the output. Okay, that time is the latency. How much time data inside the system, and throughput means how much more data it can able to take and like it can able to give the output, and also considering the quality of the data means some of the packets can lose also. This was basically networking concept, and in computer networks we'll get this one. And throughput means like let's say we have shared 10 rows or bunch of some data, okay, and how much it can get and how much it can give, and with the proper quality, what is the capability of that system, how much it can get.
So Nikhil, one question here. So when we say high throughput in Spark streaming, like
Hmm?
we also consider the quality of that, right? Like it should
Yeah,
not,
yeah. Low latency, high throughput is the preferred.
right?
Yeah.
And also it is
Is
like
it quality or quantity? In the image, I see quantity. I am not sure
Both.
if you both.
Yeah.
Both.
Both, right, Nikhil?
Yeah, both.
Yeah.
one more thing, Nikhil. So like
Quality, how do you ensure? How do you define quality? In what way? When you say quality of the data,
Mhm.
what do you mean by that?
So see, like we have shared 5 packets, okay,
Uh,
and one packet is lost. So that is the throughput. That comes under throughput. That means little bit less throughput it was. It was it has uh like some places it can fail also. Means we can lose the data. High throughput means we won't lose any data.
Hey, hi. I'm not able to. I got some problem in internet. Hello? If I'm audible now?
yes, Deepesh, you're audible. Go ahead.
I shared another image. You can take.
What?
No, we are internet discussing something about that, about throughput.
Yeah. So Nikhil has shared few images which was kind of giving us an idea about the latency and the
Yeah, I
throughput
was
of.
supposed to gonna discuss. Just wait, like we just started this, right?
Yeah, yeah.
So you can ask me question, once we at least get some more idea on this.
I think I'm clear. Anyone has the questions?
I think you're good, Vijay.
Okay.
Okay.
Deepesh, you
Yeah.
can continue.
So yeah, that's what I'm discussing. So basically, I was discussing about like the Spark streaming is having a high throughput, fault tolerant, and the fundamental stream unit in a Spark is a DStreamer, which is basically a series of RDD to process the real-time data. Okay, so basically, in what happened, as I mentioned, the fundamental stream unit in in Spark streaming is called DStream. So DStream is nothing but which is nothing but it's a basically a series of RDD, a series of RDD, okay, to process the real time data. And how does it work basically? If you just want to have just a quick understanding, so basically we have a data streamers, okay. This nothing but it's an input of data stream. And when we use this Spark streaming feature, okay, so Spark streaming will convert this, streaming data or real-time data into formation of some batches. Okay, so this is nothing but it's become a batches of input data. Okay, it's become batches of input data, kind of a, you can say micro batch. Okay, and on the top of it, there is a Spark engine. Okay, and then the actual output you can get, like, and the processed, when you do apply the Spark core engine, and then you can, whatever the processed data you wanted to have on the top of it, then you can actually get. So it's a batches of processed data. So that is just a basic understanding of your how does it work. And since there are multiple features of the Spark streaming, like uh, you know, you can it's a fault tolerant, integration is easy. You can do for business analysis. Means with the Spark streaming, you can integrate with batch and real-time processing. For business analysis, you can use to track behavior of means like you can do Spark streaming and you can do multiple things. You can achieve the speed as well as like whatever you want to do. But how does it work? Like how the workflow work? Okay. So any one of the pipeline, Nikhil, you are working into that, right? Spark streaming. Any pipeline you wanted to discuss?
Yeah, like basically we had the multiple business domains. So Vox and for theater, for some e-commerce, and all the data are coming very rapidly. And directly we were not able to feed to the Spark streaming because like it was a decoupled architecture, and data were went to we were losing the data directly by passing to Spark streaming.
Mhm,
And what we did is we added intermediate Kafka layer, and after that we processed using Spark.
mhm. Yeah.
And later, using Spark, inside Spark only, we transformed whatever is needed. And after that, they have built in the MDM API for the master data management. We passed that to MDM API. From MDM API again, we took the data, and using Spark streaming, using Kafka Connect, we stored in we write it in the target. That target is CPI endpoint.
Okay.
So a question here, sorry, Dipesh.
Yeah.
Nikhil, why you were using two resources, Kafka and Spark streaming, though they have like similar kind of, uh,
No, no,
you
not
know, use.
similar, not similar.
Okay,
Not similar.
Because see, Spark streaming, what will do is just processing. Okay, it won't store any data. Means if you have the business domains have creating data very rapidly. Okay. And Spark streaming, what will do is it will do continuous streaming. And sometimes if batches will be more, or that think like Spark streaming, wherever Spark streaming is running, right, it will be down for a few minutes. Okay. That few minutes data will be lost. But if we use Kafka there, so those data, whatever is not readed from that particular topic, they will get stored for a specific period of time till we read that, till we consume. That is a publisher subscriber model. And
okay,
whenever we want, we can publish, and whenever we want, we can subscribe to the topic and we can get the data.
okay.
And it will support parallelism also. Kafka cluster will support parallel reads, parallel writes. It is completely decoupled architecture.
Yeah, so topic, there is option to store the data, but Spark, it's everything on RAM.
Yeah,
You
everything on
might.
time. For few seconds, Spark streaming stops for development or for updation. We stop. Okay, those data will be lost. We can't store. If there is no possibility that we have to create some external mechanism. Instead of that, if Kafka we use, right, there is like we won't lose any data. It will ensure data loss in
But
any.
in your case, what was the need of Kafka? As in, you can just stream, process, and write the data, right? But I want to understand why you were using both of them.
So actually, that is the customer data. Okay.
Mhm.
And in between, we needed an MDM API. Okay. MDM API already developed by the MAF team, some other team. And we wanted to use that MDM API, existing MDM API. And this Spark streaming is there, right? So we were not sure when this Spark streaming will run and when this will be terminated. And also their data is coming very rapidly, and like they wanted to ensure we won't lose any data, that is customer data, and they are very high prioritized about the data. Okay. And they have that requirement. They want to ensure they don't want to lose any data. And also they want to add other business domains also. It won't be harder if we do Spark streaming. They have to change the code little bit. But directly in Kafka, they can write to the particular topic again from the other BU domains, and it will work. Same pipeline will work. That just have to publish to the particular topic. That's it, and it will take care of
Kafka
everything.
having a different architecture, okay. Kafka actually helps in, when you have a, it's more helpful when in terms to ingestion of any streaming process and all, okay. Whereas Spark streaming having certain other features, okay. So related to, doing analysis also on the top of it or applying the Spark functionality on the top of it. So it's kind of a D streamer. It's reading the data in certain continuous flow.
So Kafka is just basically used for subscribing to the topic and then queuing that and later using it or sending it to the Spark streaming for processing, right, Nikhil? So so that we don't lose the data.
Sorry. That is the one of the use case. Actually, main thing is decoupling. So let's say we have 100 BUs, okay, and 100 Spark streaming has to be created. But if we use Kafka, from one topic we can create only one Spark streaming. So there are many different use cases, not only one. I just told whatever I use actually.
Okay.
There are many different advantages with Kafka and Spark.
Of course, data handling,
Okay.
and then architecture is also different. Scalability is different. So there are different features of Kafka and Spark. For this, you need to understand both. Then you will able to understand a better way.
One more question here. So here in the architecture diagram which we are showing on the screen, you are seeing like input data coming in the form of stream. It goes to the Spark streaming, right? And
Correct.
basically
So basically, there is a D streamer in in Spark streaming that having a series of RDD. Okay, I will be discussing on this. If we can wait for some time, just
one question here in on this same scenario.
uh,
So the input data stream goes to the DStreamer. Micro batches are created, right?
uh,
And then basically it goes to the Spark engine for processing, and then we get the output which we can be storing basically somewhere on the target, right?
mm.
So ultimately, like we can say, ki like it is kind of a batch processing only, but the thing is the throughput is very high, right?
Yeah, I mean, when the real-time data streaming have a capability to trans or read the data into multiple RDDs in certain batch interval of time we can set, and that interval of time then a series of RDDs has been taken up as a converted and we got a batch data, and then we do that.
Okay, means structurally it is similar, only the
Similar,
throughput is
yeah,
doing real time, and other one is a batch.
correct. Okay, so I'm discussing this like how this Spark streaming workflow work. So basically, if we talk about the Spark streaming workflow, so you can read data from varieties of sources. You can, streaming data from the sources like you can read from Parquet file, you can read from any Kafka, you can read from any, AWS Kinesis. Okay, AWS Kinesis also you can use that. Okay, you can use from Kafka. You can use from any Parquet file. You can read from any Akka, varieties of sources you can use that. So these are your streaming sources. Then you can also read data from any static data sources also. You know, now static data sources either from DBFS, okay, Databricks file system you can read. You can read from any MongoDB. You can read from MySQL. But you have multiple other data, right? So that is not streaming, but you can actually get it in certain interval of time also. You can read that those data. Periodically you can read that, and the streamer will able to do transform the RDD and apply the concepts on the top of it, right? And then this Spark streaming will come. Okay, a Spark streaming will come, and then you can on the top of it you can apply Spark SQL, and then you can store into that. So one architecture I will tell you. So basically one architecture something like this. So let's suppose you are reading data using Kafka. Okay, you are reading data using Kafka, and you have applied Flume for ingesting it. Anybody know what is Flume?
Yeah, so that's another, framework for streaming and processing data, and I think it has high throughput than Kafka and Spark Streaming.
So Apache Flume is also a distributed, reliable, and available system for collect or aggregate ingesting the data in a ingesting streaming data. This is majorly used for ingestion of a streaming data, either majorly like log generated web servers, applications, sensor data. So these kind of thing, can also be used. So that is also one of these stuff. Then you can read data from any, let's say, call SDFS or from any S3 object in AWS. You can read from any kinesis. Okay. You can read data from, let's say, called Twitter. So variety of sources you are reading data. So when you are applying Spark streaming, then you can this data, whatever the ingestion is happening, you can store inside any other place. So you can read into a Parquet file or any SDFS sources or any databases and any dashboards. Okay. So then once the data you got from this SDFS source, wherever the data you are getting, so how I have told you already, like it will stream batch, it will convert into batches, and then that's how the Spark engine will come into the picture. What I have told you just now, right? And then that's how it's processed. So basically, how it is doing that, how it is converting the D streamer. So when it's reading the data, so let's suppose there is a D streamer. Okay, there is a D stream. So basically, what will happen? So in certain interval of time, so any data from time 0 to 1. So let's say we are reading after every 1 second. So it will first generate the RDD of data frame in time 1, like in 1 second, 1 minute, whatever you take. Okay. Then whatever the data will rest is, it will read here from data from time 1 to 2. So this is the another RDD going to be created, time 2. Then it will read the data from time 2 to 3. So this again going to be at time 3. Similarly for 4 as well. So that is how the input data stream divided into discrete chunks and discrete chunks. So like this in certain time interval, how this data is going to be taken up and how from data from uh, time 3 to 4 has been taken up, right? Then if you wanted to understand, let's say you wanted to understand, you wanted to count something, okay, from this, what is the count of total persons between them, or you wanted to add something, you wanted to apply any operation on the top of it. So what will happen? It will again, it will try to make analytical understanding by using, like Spark core engine and all. So there is an operation will happen. So flat map operation, let's suppose it's happening over there. It will it will understand, it will extract. We are extracting some words. So from word, it will apply from 0 to 1. What is the words were there? Okay. What is the word from time words from time 1 to 2? Similarly for this, what is the words from 2 to 3? Right? So this is streaming, it's like I'm getting the words out of this. So this is nothing but it's extracting words from an input stream. Words from an input stream. Yeah. So did you understood the process, what we are doing? We are actually reading the data using data streamer. The data streamer is getting utilized, okay, and converting the data into like the chunks of RDD, and that's how the further operations will happen, and that's how things proceed accordingly. Any questions?
No questions, Dipesh. I also want to understand if you can talk a little bit about sensor as a source, right? For example, if we have sensor and data is coming in analog form 0 or 1, sorry, digital form 0 or 1, then how will Spark streaming look like, or can Spark streaming deal with the sensor data? Yeah.
Uh, Sensor data, primarily better managed. What I have used is Flume for managing the sensor data. Not used, this called Spark streaming. With Flume, I have did that, but I can look into that. But before this, let me just give a good idea about this, how Spark streaming handles. So the process of Spark streaming is that it's have a certain flow, okay, while we are looking into that. So basically, what happened, whenever you're reading a data, okay, so using Spark streaming, so the very first thing is happening, the Spark context come into the picture, okay, sorry, streaming context come into the picture, the Spark streaming context come into the picture. Streaming context, you get it utilized using DStream, so we use DStream of that, okay, then certain caching will happen, okay, certain, broadcast variable checkpoints are there, basically for fault tolerance and to understand like how this is happening. So certain accumulator broadcast variable and check.
Hi, Deepesh. Sorry to interfere. This is Shyam from the support team. Yeah.
Sham. Sham. Manoj, I was expecting Manoj. Okay. Sham, but yesterday Manoj came into the session for helping us for,
Okay.
so we were expecting him.
All right. So somebody sent a mail. I think it's Santu. So he's sent to join the call immediately. So we can. There are some issues.
You are from Nevo team?
Sorry.
You're from Nevo team?
Yes. Yes.
Oh, that's good. So basically, yesterday he helped us to create the workspace in Databricks,
Mm-hmm.
but majority of us cannot create cluster.
Okay.
Yeah. So will you able to look into that?
Yes, of course I can do that. So we have yesterday. We have the morning call because there is a solution.
No,
So.
we created workspace, right?
Hmm.
We were able to create workspace,
Okay.
but after creating a workspace, when we are trying to deploy the cluster on AWS, that's showing as an error that it's not allowed.
Can you please just show me that so that I can identify if it is possible?
Yeah, just
Yeah, you have to click on that. You have to go to the next button, that AWS console. You will not be able to log in. So your right side, in the right side panel, in the third option, in the third tab in the browser.
no worries. First, let me log into the Nevo Pro.
You can just refresh the page. It might be, it is already in started state. Yeah.
So this is my workspace, right? So when I'm creating a cluster to run that.
1 second, Deepesh. Can you just come back to that New Pro subscription? Yep. Wait for a
Where
second.
is the console?
Yeah, no, not in the console. That one. Yeah. Just wait, just close this one. That one close, and just refresh in the right side. The right side near to the start complete option action, left side. In the left side, stop button is there, right? In the right side, you can see a
Yeah.
there is a refresh button. Just okay. Just console is open. Okay, 1 second. I am just checking the status of that particular account. Okay, this is a user 01. Okay, so that setup challenge is completed. Let me see. Okay, so now you can okay, now okay, now you can go to that AWS console. Can you go to the AWS console? Yeah. So now here go to IAM. Go to IAM.
PDF based. IAM, right?
Yeah, IAM. And roles. There should be 2 roles should be created. One workspace. Okay. Oh, those 2 roles are there. Correct. So inside, can you please click on this workspace deployment role? Open that. Can you go to the trust relationship? All right. So the STS external ID is there, right? Can you please confirm whether it is same with the your Databricks ID? Can you go to the Databricks console? Yeah. So yeah, click on that Deepesh work. Yeah, there. Okay, copy that. You have to change it with the external ID, that STS external ID below. Yeah, that one.
This is same, I believe.
Can you please confirm whether it is same or not?
It's 391E, right?
391E, yeah.
And
that is a different one.
That's a different.
Yeah.
Deepesh, every day when we actually log in, I think these roles are newly created here.
Exactly.
Okay. So every day we need to make changes here.
Of
Yes,
course, this should be like it's an everyday routine. So we cannot keep these things like we cannot hold anywhere.
So
So
here,
the roles will be created. There are 2 roles and one S3 bucket will be created, and you have to make sure that you are configuring the same Databricks ID with this trust relationship things.
so I have done this. Now again, I need to make changes this to any other place.
Yeah, now another role also. This is for one role, right? Another role is there, right? This is for the deployment role. Another one is the storage role. Yeah, here also you have to do the same thing.
Add permission or storage policy.
Just click on that trust relationship, and here also you have to do the same. There is a document which is provided. Did you received the document?
Arshia told me for my account, she has made, like I don't have to do this on every day.
It's not possible. That I need to confirm with Arshia once.
This is the same one, right? E.
D6AE.
Yeah, it's done now.
Yeah.
Now I can create.
1 second. Let me go through that. This one once again. In a few seconds.
I guess we need to add some ARN also, right?
Yes. We need to do that. I'm just checking it.
I have pasted the steps that I have noted down for some reason. So you need to edit the S3 policy also. There you need to.
I'll just tell you what are the things we need to do. All right. Okay, now we have added the workspace role and the resource role. So, 1 second. Okay, the trust relationship is also done. Workspace deployment role trust relationship is done. Okay.
I think in S3 bucket we need
Yeah,
to,
now you have to go to the S3 bucket.
yeah.
So in the S3 bucket, you can see permissions, right? You go inside. You can see permissions. Permissions. It's the third button. The third one. The top side objects properties. Yeah, permissions. So below, we have to edit. Below, you have to edit that in the change where you can see AWS principal database account ID. The top one condition. The string equals.
Yeah, this one, right? This is
Yeah, that one you have. No, that is a different one.
okay.
This also you need to change. Now these are the only changes you have to make. That is already everything already. All things are done. So the changes are made. We have completed the changes. Now you can save these changes.
I guess we need to add some ARN as well, right?
That is while we do the creation.
Okay.
So the one more thing is this condition. It is not. I think it is not still changed. Can you see? Can you see that? Yeah.
That's all right.
Yes.
Deployment role here, and we need to add in the storage role.
Right.
Sorry, I didn't.
ARN already I mentioned. Okay.
Not this one. If you go to
Deployment role, when you click, you will get a ARN. For that ARN, we have to copy, then open the
Yeah,
storage.
this
There
ARN
we have
you're talking, right?
the role ARN, inside the role you will get an ARN. Not here. Inside the role.
IAM.
Inside IAM, there are two roles, right?
Yeah. So we need to copy the role like ARM from the deployment role and paste it in the principal tag of the storage role. Right, Mayur? You are saying that only, right?
Yes.
This you're talking about workspace storage role?
No, first you open the deployment
Deployment role.
and there is a ARN here on the top.
Yeah,
Yeah,
copy that.
Now open the storage role. Go back to the roles and open the storage role. Here only.
Come back, come back. Just
the
back.
IAM, you have to go back.
Just click on back.
Roles.
Yeah, again roles.
I copied that.
Copied that. Okay, click on that roles. The second role, the workspace storage role, the last one. And open the storage. It is inside the trust relation policy. Let's
Click on trust relationship.
inside the trust relationship. Inside the trust relationship. Yeah. No, inside the trust relationship. Come back.
Go to roles.
Once again, roles, storage role. The last one. Trust relationship. Second one. Yeah. Here you can see that ARN, right?
This one, right?
Yeah, that one.
Don't just like append the newly.
Into this. So just after AWS colon is there, right? You have to open a square bracket.
AWS column.
This basically an append that role which you append that ARN.
This you're talking 4143?
Yeah. So like make it a list basically.
I think this is the same, I believe. No? 119. Let's change. This I need to copy.
Yeah, copy
Yes.
whole thing. Cut that from there.
I'll do that first. Let me.
Not there. Add a square bracket.
Here.
Yeah, yes. And a comma, right side. No. It should be yeah. In the end.
I need to paste here.
Not here. In the right.
Append it. Go to right and like basically add a comma there at the end after the double quotes. Not here. But
remove that comma. Come to the end of that line. Add that. Come to the end of the line. Add a comma. Paste that role. Add an apostrophe before that ARN. Double. Yeah. Come to the end. Come to the end of that. Here also.
And remove the last one. Yeah.
What?
Remove that last line. The below one. The
Yeah,
last.
I will remove.
Not all. Yeah.
Yeah. Update policy.
Yes. Update policy. Yeah.
Okay. It's done.
Yeah. Now you can come to the Databricks account. And you can create a new cluster.
Cluster can be created.
Yes. There should not be any issues after we made this might of changes. There should not be any issues.
It's not happening. Let me just create a new computer.
Do we need to create a new workspace or only computer is fine?
Since I already created a workspace, so I think that should work. No, it's not connecting. Saying this. AWS authorization failure.
1 second. It's not a assume role on that. Assume role, assume role, assume role. 1 second. Divesh, I will do one thing. Give me 10 minutes. I will get back on my system and I'll try
Sure.
to create a Databricks account from my end and I will check there for the errors and I will solve it. Right?
Sure.
All right, Divesh. Yeah. Thank you.
No, just allow me 1 minute. I'll be back. Sorry, audible? Hey, hi, Sandeep, you are saying something? Hello?
No, Dipesh, no one is saying.
I guess Sandeep is also getting the same error.
No worries, we are anyway, we are working on that, so we are discussing this thing. Okay. So I was talking about the streaming process in which how we can, like get the how the processes are happening. So once the streaming context, DStream caching, once you accumulate the process of accumulator, broadcast variable, checkpoints. Okay. So in DStream, there are certain things happening. Okay. So in DStream, what actually happening over there is, let me show you. So as I mentioned to you guys, so here, one is the input D stream. I'll show you while creating as an example, input D stream. You would have a data D stream, transformation happen, and then the output D stream. So output D stream will let you allocate at certain place. Okay. So let's start by one discussing these, how the process actually happen. Okay. So when I say streaming context, okay. So streaming context, I told you, like you have an input data stream and then the batch of input data will happen. Streaming context actually consume a stream of data in Spark and then it actually registered an input data stream to produce a receiver object. Okay. And like whenever streaming context is like allowing them to consume that data streaming, whatever the stream data is there, input data stream producing kind of a receiver object over there. So this first that we are discussing is streaming context. So it's consumes a stream of data in Spark and then registers and input D stream to produce a receiver object. Okay. Now, basically what happened whenever a streaming context object will be created from Spark context object. So Spark context represent the connection to a Spark cluster basically. So this streaming context, object, like being created in certain way that it represent the connection to a Spark cluster and can be used to create RDD accumulator broadcast variable on the cluster. So here you can say that Spark context represents the connections to a Spark cluster and can be used to create RDD. So this actually allowing us to create RDD, broadcast variable, accumulator variables, whatever you wanted to create. Right? And how do we create? From Apache Spark, we directly import the Spark streaming over there. So we import like this. We import org.apache.spark. Okay. Then we import Apache Spark.streaming, and then we create the streaming context. Okay. So we create the streaming context, or maybe on PySpark, we directly import PySpark streaming context over there. So that is how we import we actually utilize this streaming context. Okay. So that is allowing us to use all this Spark functionality on the top of that, right? Then the next we have is called, DStreamer. Okay. So as I already mentioned, the DStreamer, what's the meaning of DStreamer? Who gonna tell me? Nikhil?
Discretized streaming.
Very nice. So DStreaming stands for discretized stream. Okay. It's nothing but it's the basic abstraction provided by Spark streaming. It's a basic abstractions provided by Spark streaming. Okay. And it's a continuous stream of data. So this will allow to do a continuous stream of data. Okay. And already I discussed this here, how the DStreamer actually works. So from certain time interval, when the data come, so here is the data from time certain interval, it's actually come. So basically it's receiving from source or from a process data stream and generated by transforming the input stream. So what happened, as I mentioned, the DStreamer represent by a continuous series of RDD, and each RDD contains data from certain interval of time, right? So that is the meaning of, like how the data stream actually works. Or on the top of this data streamer, as I mentioned, okay, whatever any operation applied on data streamer translate to operation on underlying the RDDs only. Okay. For example, as I mentioned here, the flat map, right? So, when we are converting a stream of line to words, when we are applying the flat map operation, okay, on each RDD in the D stream, to generate a word of data streaming on the top of it. So here we have taken this example and we have discussed like how this data stream are looking into that. Then once the, once the data stream will get, as I mentioned here in this example, once the data stream read the data. So here, what we're gonna do that once the data stream are generating RDD, also all the stuff, it's actually putting into the input data stream. What is input data stream? Input data stream are the data stream that representing the stream of input data received from streaming sources. Okay, so in D stream, there are three things. One is the input D stream, one is the kind of a data stream transformation, and then the output stream. So already I discussed this thing here. So D stream, there is an input D stream, there is the stream transformation, and then there is output D stream. So in input D stream, what's happened? Basically, when you are, like you can, any input data stream, let me need to charge it. Hmm. So this input D stream further, like goes either into the basic sources or advanced sources. So when in this data is into basic sources, what is the basic sources in Databricks? You can store into the file system. right? Database file system, or any with the help of any socket connection, you can connect any other places. Okay, or in the advanced sources of this, you can using Kafka, Flume, Kinesis, you can store or put any other places. Okay, you can send back to the data using Kafka, Flume, Kinesis. That's all. So input data stream is nothing. If I have to mention here, input data stream are the data streaming that representing the stream of input data received from streaming sources. Okay, received from streaming source. Okay, and once you are done with that, you know, like your data streamer put the data into certain operations. Multiple RDD operations will be allocated like this. Multiple RDD operations are here. Multiple of that is there. Any events happen, then your data stream got associated with the receiver object, and then the source is stored into Spark memory for processing the data. So basically, the Spark memory get utilized in order to do this process whenever the receiver is receiving that. Okay, so that is how this processing happens. Then the next is the transformation on D stream. Okay, so what are the most popular transformation we do on this data stream? Like, as you know, there are certain transformation when it's happening. So the most popular transformations are like for map, flat map, filter, reduce, group by. So when you're doing these kind of like yeah. So when you're doing transformation here, you can do multiple transformation on the top of it. So transformation on RDD of streaming RDD allow the data from the input data stream to be modified similar to the RDDs as we modifying. And because the D stream support many of the transformation available on Spark RDD. Okay, so this input D stream, whatever transformation you wanted to do, flat map, filter, you wanted to do reduce. So transformation allow the data from the input D stream to be modified similar to RDD. Okay, and D stream support multiple of all these operations. Okay, so whenever you have, let's say, kind of any D stream data is there, let's say there are multiple D streamers are there, it's going to be transformed into another D stream. So let's say it's a D stream 1, it's a D stream 2. So it's going to be transformed in multiple transformation process. Kind of this thing. Yeah. And there are some split points are also there. Okay. So multiple map functions, flat map functions, filter functions, reduce functions can be applied on the top of it. Right. So, you have any questions on that? You wanted
So
to know?
Dipesh, once the RDDs are created, so how long these RDDs are, I mean, they exist in the backend? How long these RDDs exist? So suppose if the time interval is 1 minute, so after every 1 minute, the new RDD will get created for a 10 timestamp of 0 to 1, 1 to 2 minutes. So how long the data persists in these RDDs?
How long? Because it's series of transformations are there, right? And RDDs itself created a record. So, I don't understand like what exactly what you are trying to ask. You know that whenever there is a RDD, how long it is means it's there.
Yeah. because in the streaming, you will be processing the continuous data, right? And after, suppose you gave an example that the RDDs will get created for a specific interval of time from 0 to 1 minute. If our interval is 1 minute, then 0 to 1 minute, one RDD will get created, 1 to 2 minute, second RDD will get created. So likewise, there will be so many RDDs and they will have the data, correct? So for how long these RDDs will be there stored and the data will be stored in these RDDs?
Um, See, so basically the lifetime of an RDD in a D stream depends on how long it's kept in memory or in persisted storage. So based on these two things, it depends. If how much the persisted storage it is there, and it's basically kept in memory basically. So the factors that the RDD in a data stream like it's influencing is based on the batch interval. Like if let's suppose if your D stream is divided into batches of data, okay, like so an RDD is created. Let's say if it's 1 second, 5 seconds. So that determines how often new RDDs are created. And once the RDD is processed, it exists temporarily in the memory, but without any specific action, like because it's creating over there. So like caching or checkpointing is there. Okay. That's why the checkpoints are there over there. So it will automatically cleared after it has been processed over there.
Okay, so you mean process means when we after the transformation, if we do some kind of actions, then it means it is being processed, right? Or
Yeah, means once your transformation and persistence done or any window operations you are doing, so then you can till then it will there, and then if you want to get it into the garbage collection also, so by default from there also it can be deleted.
okay.
So basically RDD also have this Spark also have a garbage collection process. So by default, the Spark also clean up RDD after they are no longer needed. So from there also it takes. So few points that on RDD depends,
Okay.
based on what kind of transformation types you have used, okay, in the streaming. What are the batch interval, um, persistent caching process, any other operations if you are doing like windowed operations and all. So
Yeah, there are windows concepts, right? There are sliding windows, tumbling windows, session windows, custom sized windows. So those many intervals, this RDD will get stored. And let's say like we want to handle late arriving events, like let's say 1 minute window we created, and after 1 minute, like late arriving event comes. So there we'll use watermarking, and till watermark time, this all the RDDs will get stored for the temporary till whatever time we specify.
Yeah, like the example you said, let's say if your window size is set to 10 minutes and the batch interval is 1 minute. So RDD for the last 10 minutes means 10 batches will be retained in memory until the window size. So 4 or 5 points are there. Based on that, you can, it's something you can look into that. Yeah, any other question? Yeah, so that is what about the transformation process, multiple either you are using group by any kind of transformation process you are using. Then the windowed operation that I'm talking about, when you talk about the windowed operation, so basically what happened, let me just quickly give you highlight on this. Let's suppose, as I mentioned, Spark streaming will do windowed operation. So what is windowed operation? Computation basically. So when Spark streaming Windows computation allow us to apply transformation over a sliding window. So sliding window is like this. So this windowed computation, let me write in a better way. Allow windowed computation. Okay, which allow us to apply transformation over a sliding window of data like this. So let's suppose you have a original D stream. Okay, so here is the RTTs of data in certain interval of time. Okay, so this is time 1, this is time 2. Now here we are doing a windowed transformation. How? So let's say this is another data and this is the sliding window. Okay, so here what we are doing is okay, so this kind of operations where we are doing the sliding operations of windowed operations, you can say that. So on certain interval of time, okay, so this is called window based operations where you are able to grab at a certain point of time. Okay, and this you have the D stream window D stream you would able to define. Okay, so when you are applying the windowed transformations, okay, sliding window transformation, so that is also the transformation process. You can do that. Got it? Yeah. So moving further, as I mentioned in a D stream, there is a transformation input stream and output stream. Output stream operation basically allow D stream to be pushed out to the external system. So when there is an external system like database or file system, so output operation trigger the actual execution of all the data stream transformation. Okay, and like you can save into Paraquat file, Hadoop file. You can print. You can print as a text file. You can save as an object file. So that is how the output operations are there. Got it? Yeah. Now caching persistence of this is nothing but it's a DStreamer is basically allowing developer to cache persist the stream data in memory. Okay, so when you mention this here, so caching is the cache and the stream data in the memory. So basically this is useful for all the data in the day stream will be computed for the multiple times. So you can persist the day stream information into multiple caching nodes. So that is what the caching. Multiple variables you can utilize like accumulator variables to accumulate certain information added through some associative commands and all. A broadcast variable you can use, so these things that you can utilize. And then the checkpoint. Checkpoint is the important part in this process. So what is checkpoint? Let me just quickly tell you. Here if I
Yes,
talk about
before we go to checkpoint, what is the use of those variables, accumulator and broadcast variables?
So basically, accumulator variable or broadcast variables. So when we talk about broadcast variable, so when you are programming, so broadcast variable allow any programmer to keep a read-only variable. Okay, keep read-only variable that is cached on each machine rather than shipping a copy of it with some certain task. So that is where, it's actually keeping read-only variable kind of understanding out of the data. So it's keep every node a copy of large input of data set in certain efficient manner.
So it's like a kind of a backup or something like that.
Uh, yeah, I mean, it's actually keeping certain kind of information in which in every node a copy of certain information, large input of data set are kept in an efficient manner. So whenever Spark attempt to distribute broadcast variable, it reduce the communication cost between all the nodes. So for that reason, we keep it. And then we can clean up as well as later on. Yeah. Similarly, the accumulator. So accumulator variables, are used to implement any counters or some kind of thing when we do. So it's accumulate, what's only added some associative or commutative operations whenever we look into that. So then we use. So basically, it is being utilized accumulator tracking, for understanding the progress or running status of the stages and all. So then you accumulator variables are there of this that you can utilize of Spark. Similarly, broadcast variable is there. Okay. And then the checkpoints. Checkpoints are also one of the part of this in this process that is keep make the whole process into agnostic features where it's like a checkpoints like in gaming we do, right? So any 24/7, some resilient failures if it happens. So it's kind of this checkpoints are making into that. Yeah. So three thing is that accumulator, broadcast, and checkpoints. Accumulator, I told you, that's for counting the stages. Progress, you can keep the track of this. Broadcast, keep a copy. Copy for reduce the communication cost. Communication cost between the different nodes. Okay. Checkpoints is nothing but it's a, like kind of a resilient feature for, like checking. It's saving information, defining some computation process. So it's kind of a meta checkpoints are there, data checkpoints are there. So it's kind of this, it's saving certain information. So, uh, like it's 24/7 resilient process is happening to check if it's what's happening over there, and it's keeping the record of data checkpoints and meta data checkpoints, kind of this thing. Okay. If you have any questions out of it, what we have discussed. Streaming context, DStream, caching, accumulator, broadcast, checkpoints, these things, any one of them. Anyone have any Twitter account here? They're not going any Twitter analysis as of now, but if you wish, we can also do that for you. Let me show you something. Yeah. So this is the official documentation where how this different streaming process. My screen is visible to you guys? Hello?
Yes, it is visible, Dipesh.
Yeah, so here like how from the multiple sources we are able to read converting to batch processing, right? Then how to read? So basically, if you might have been reading the data from on AWS or some streaming process will be there. You could have seen this. I'll tell you with different examples. So here you can see that from PySpark, we import the Spark context. Okay. Then from PySpark.streaming, we import the streaming context, right? So basically streaming context, as I mentioned, the very first is the streaming context. Once the streaming context is there, now certain batch of interval of time you can select. Okay. Now you can select which context from where you wanted to connect this. Okay. And what is the interval of time you wanted to use? Here we are doing a network word count. So we have defined this. We wanted to do a word count. Okay. Here you can see that. Then it's reading the data after every 1 second. So batch interval time is 1. Good enough? Hello?
Dipesh, can you please explain again what is that Spark context to arguments or parameters that is given?
Spark context is like similarly to like we have defined the Spark context before also, right? So we were using the Spark functionality. Yeah. So we just defined the app name like it's a network word count we are doing. Okay. So uh like we are defining certain working threads. So we are creating a local streaming context with 2 working threads and a batch interval of 1 second. So for that we have defined this. Okay. Then here uh, we have uh, taken up the D stream and we wanted to connect with, let's say, if you wanted to connect with some certain API, you can define the IP address and the port number, but that should be connected internally. Okay. So you can read data from any other sources also. Either you are reading from Spark, either you, sorry, Kafka, any place, wherever you are. This is the socket to connect with the stream. So it's a socket text string to connect. So let's suppose if you have a local streaming you're doing. So when you're doing a local streaming, like whenever there's a local streaming we are doing, we can use that local host. And then this is the port number on which it is connected. Like in your IPNB, you know that you have an ID and then the port number was 8080 kind of thing. So if it was there, you could have connected. If you have a web address, then there is certain more process we need to connect with that. Okay. And we are using a transformation that is called flat map. This is a flat map. Okay. And this line going to be splitted. So let's say you are sending the data, let's say call, hi, my name is Dipesh, hi, hello, 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 whatever you are mentioning input inside that. That input will be going to be, splitted, tokenize the data. And then here, this functionality we are using, that functions going to be map and do X plus Y. So it will be count the word. Let's say if the word is Dipesh is 2 times, it will count like that. And then you will print that word. Okay. So the RDD going to be generated and there's going to be printed over there. Okay. So once that got printed, we are to start the computation. We started here start and then to wait for the computation to terminate. Then we can use SCC await termination, right? And to start this network word count on your command prompt, we can write nclk 999. So it will invoke the, it will invoke the, this local host. You can start putting the words. So you can see that once that output, when you started submitting some certain words over there, it will show like this. So hello is 1 time, word is 1 time. This the output will be going to be displayed like this. Got the point?
Yes, Divyesh.
So now moving forward, I will tell you one example how you can create on Databricks Spark streaming process. For this, we will first create some Databricks file system. We'll be creating some kind of a document, some certain data that we will try to stream, and that's how we'll be reading that data information, and that will applying on the top of it. So that is an idea. Okay. So before this, if you have any question, you can do ask me. Yes, doing the Spark structured streaming. So since we don't have as of now any structured data, we can read from Spark, APIs. We can read from Spark structured streaming also. There are some APIs that it will give us some structured data to be read. Okay, we can read that, but let's create our own data. So what I'm supposed to gonna do that is I'm going to create some data, okay, and in certain form of files, and that data I will be reading every time. So here, let's create that data. Basically, how you can create a data. See, right now I'm going to create some certain data. Let me create here. Uh,
Like streaming data, you are saying?
yeah, I'm creating some data to be streamed in Spark. My screen is visible?
Yes, yeah, Dipesh.
Yeah, so I am going to create some of the worksheet. Here, let's say some sales information data I'm going to create. So like, so here I'll show you few files I will create so that those data can be up here. Here, so what all the things I will be putting here is, let's say I will mention here the file, the shop, okay, let's say sale count. Okay, so these three columns I'm putting here inside it, okay, and I will be mentioning some of these. So I just wanted to show you some kind of a count on the top of it. So for that, I'm mentioning file. I'll keep it like file one, and here, let's say I'm mentioning the shop is, let's say from Amazon, I have purchased something, Amazon, and the sum of count is, let's say, call uh, just a second. So I can mention any one of the values here. Like let's say I mention count is 100. Then similarly, for a few more files I can create 2, 3, 4, 5, right? And keep everything similarly that. So here, let's say Flipkart, the total count, let's say call 50. Then Myntra, the total count, let's say call 20. Then let's say call from Snapdeal, the total count I'm taking what 10. And let's say from Alibaba, I'm keeping it null, right? So this file I have with me, and I'm going to save this as in a CSV file. So saving it as a CSV file just for a streaming purpose, right? So we are, like for a streaming purpose, I'm just doing it. Then 3. Four. 5. Yeah. So, and see, we are creating multiple files. So I'm going to create multiple files inside it. So here, just change the file name inside this. So file will remain same. Just so in, let's say 2, I will be going to just make changes of this file. So it will be 2 only. Yeah. So just let me check if it has been updated or not. Yeah, it's file 2. Similarly, in file 3, just change the name file. Because it's 3. Yeah. So we have all the files with us now, and let's back to the here. Now here I'm going to do one thing. See, first, as I mentioned, we need to, ingest the data. So for that reason, we will be going to ingest the data. We will be going to create some kind of a Databricks file system. And, I'm going to read the data in certain way. So I'll just write some query. So I have named my structured data in which I have taken, I'll be reading the data in a structured streaming. For that, we are supposed to gonna define a schema here, and let me just, yeah. So here, what I'm doing, I'm just defining a schema. If my screen is visible to all of you,
Yeah, it is.
so we are defining schema. Yes. Sorry. Yeah, I was talking about schema. So here we were defining some schema for our streaming data that we are supposed to gonna read that. So we are defining a schema. So okay. So how I'm going to do that? So basically, as you remember, if you remember that, like when I have in the very first, I have created the schema, I have imported few basic, uh, you know, uh, uh, packages. Okay, but again, I need to first run the cluster. What all the stuff we have imported for creating a schema? Hello?
Struct file, struct type.
Struct type, struct field, integer, integer type, and string type, right? These things we have imported, and here we are defining a schema. So here, in order to define that, here struct type is nothing but yeah. So here I can define this struct field, and I have taken up in our data set 3 columns, right? What was the column? I think file, shop, and
Sale count, I guess.
sale count. So here struct field, the file will be a string type. Okay, and true. Struct by field, let's say shop, as in string type. True. Struct field, then sale count, integer type. Yeah. So this is your, like a schema that we have created. Meanwhile, it's running. Yeah. Now, see, we are supposed to gonna upload, this data into, inside a Databricks file system, because we are not ingesting from Kinesis or anywhere else. So we'll be importing inside, we are creating three tables. One is the stream checkpoint, one is the stream read, and one is the stream write for de-streaming, right? So we are creating three different, folder inside Databricks file system. Are you getting my point?
Basically, you will be reading, and then checkpoint means staging, and then
Checkpoints, yeah, I mean, like, understand, like, it will be, one is for read, write, one is a checkpoint in which all the, when we are storing a data, there will be some certain kind of, it will be a checking if any RDD fails and all, and that's how it's a kind of a meta information will be reciting. So for that, stream checkpoints will be there, read will be there, stream write will be there. So three things I'm supposed to gonna create. So either I create it manually, these folders, or either I create by using DB making directory inside that. So there are some database utilities by which I can also create it. So I'll be creating DB utils dot fs dot dir. Hello, anyone saying something?
No, Dipesh, continue.
Yeah, so DB util is fsmkdirs, and here I'll be creating in a file store. So you know that when we read this, it goes up to in Databricks file store. So here in file stores, uh, file store slash table, I'm creating, that's one is called stream checkpoints. Checkpoints. Okay. So one I have created. Similarly, I'll be creating other. and write. So first I will show you how this data going to be read, and then later on, I will delete this. I'll have to delete this. Why? Because so I'll show you how to store in a paraquet file. So that I will also show you. So for this, let me just write the code for us also. I'll just run it later on, but uh, so basically what I'm trying to do that is, see, once I'll just remove this, remove the directory. So I will create a fresh new directory also later on. Yeah. So now, here, since I'm going to show you like how the directory going to be created. So here you can see that in Databricks file system, when I just create a new table, in Databricks file system, I would have a few tables will be going to be created, right? So how this process will happen, like I will be going to show you here. Let's suppose in my table, when I'm going to create in read section, we'll be reading any kind of data over there. So here I will be going to read the data. Okay. So first I'll just quickly run this. I just run this and I'm going to create a directory. So here in Databricks file system, when I'll show you, just a second. I don't even aware like how can I access this file store? I'm not able to access here. In the premium, it's easily accessible. Are you able to see? We have created a directory in file store, right? So this is file store tables, but when I'm just refreshing, it's not showing in tables. It should show here.
You can click on create table. There only. Catalog. Create table. Inside is select.
Uh,
No, inside select. You can upload
Broad select.
right?
Broad
Select.
select.
okay. Sorry.
Yeah,
So
here.
these are the points. Okay. So here, we have all these three directory that we created, read and write and all, right? So whenever I'm going to upload here any file here, let's say I will upload the file 1, 2, 3, whatever file I will be uploading here, I will able to, like stream the data here. So I'll show you here. So here, just let's quickly read, read the data. So just to read the data, I will be going to read data like this. Here. So here the data frame I'm just reading here, that is spark dot read stream and dot format in a CSV, right? So and the schema we have created, the schema created, we named it schema defined, right? We defined as a schema defined and dot option. Let's make their header true. Header equal to true. get this separated by the CSV file. So separated by comma. Comma. Yeah, and we can load the data. So the data we are loading this one. Read. So we are reading this information from the load from here. So whatever data will be storing will come here. So here, and then I'm going to count this data. So here, the new data frame is going to show us to group by the sum based on, let's say, called sum of sales count. So df dot, I'm just putting the transformation group by based on, we call shop, and then we are doing sum of sales count. Okay, so here I will display the df1. So now when I run this, you can see that what will happen. You know, it
Display spelling is wrong.
yes,
And sales count also. Sales count.
Sale count, I guess, not sales.
as CL count. Okay, here. So you can see that. See, when I so it start streaming initiated, right? So right now it's streaming the data, but there are no certain values inside it. So it's keep streaming right there. So when I'm going to, you know, process it, or when I'll upload a file inside this, so the data will be get streamed here. Okay. So here is in my file. What is that? Yeah, in this read, I will be going to, yeah, let's read the data here, and I'm uploading the data in my desktop, the data. Meaning, let's read this data. So this data we have read, and now see, once I read this data, okay, here it's just reading it again. Yeah, can you see that? So it's reading. Yeah, but why it's showing like this? Null. You didn't make any mistake. It's showing SOP is also null. Sum of sale count is also null.
I think source folder we didn't uploaded any data, right?
What you say?
Source the DBFS directory in stream read. We don't have any files, right?
Loaded, I guess, no? No. No,
Source. No,
We have loaded, but data is there in that source file, or it is empty.
this one.
yeah.
Yeah, because it's 0.1 KB, right?
Is it uploaded?
The data is here. Data is there.
Yeah, uploaded.
The schema is file string shop. Oh, sales count. So I take an integer type only. It should be right. Is there any problem? CSV file? Can you
So
try?
we can do one thing. Can you stop this one and in first line instead of read stream, can you make it read so that we'll get to know if any issue is there in streaming? Yeah, you can make that read, and we can. Yeah, can you interrupt and exit re-execute this? We'll get to know. Re-execute this. Okay,
There are some values that's not able to read properly. Why it is so?
Can you do db.fs.ls in that stream read? Is that uploaded or not? You can check.
Yeah, or the path is something else.
Yeah, something is.
If the path is something else, how it will able to read this shop and sum of sales?
Are you sure the separator is colon semicolon for the CSV?
That could be a problem. Let me check.
Maybe check in Notepad plus or something. Maybe it's comma. Like there is
Can you see that?
a semicolon here, right?
Yeah, separator, option
Yep.
separator.
Option separator. I have selected right.
Is it
It's
semicolon?
comma or semicolon?
Huh?
You have
Is
selected
it comma or semicolon?
not
You
really.
have selected semicolon.
Just a second. Oh, option separate. What is right now with the comma only?
No, comma.
Oh, selected semicolon there, not comma.
It is. Not, it is
No,
not.
no. I separated by semicolon. Oh, okay. Just a second.
It looks the other way around.
It's a comma, right?
Hmm.
So there you have written
Comma.
Yeah.
Instead of semicolon, it should be comma, right?
comma and double quotes.
Comma.
Yeah, now we can make it streaming, read streaming, can add it back.
Yeah. So the data is we read here, and let's say I will be uploading a more file like this. You see that. Once I do that, this I have made it sum of sales, so it should show 20 like that. Indra should count. Got it?
Okay.
Yeah, so it will keep streaming this process. So the more I will add,
It is as per the sales data coming in packets and it is getting updated.
it's getting updated over there. Will you please try this? All of you, I want all of you to try this. I'll just share this with all of you. I sent this code into the chat.
Nikhil, one question here. Are there?
Hello.
Yeah.
Hello.
Yeah, Deepesh, when you start streaming, it's keep on streaming the data until we interrupt, is it?
Correct. We need to await or either need to define the time of streaming. We can,
Mm-hmm.
like I've shown you the example over there.
Mm-hmm.
You're done?
So Dipesh, it will keep on executing, right? It will keep on looking for the new files from
Correct.
that file, the path.
Correct. We can define like after a certain 2 minute or 3 minute it should run, so that we can define like I have shown you. So while we're doing here,
Correct, correct. At the beginning, we can define the interval.
define in streaming context itself, we can define that streaming context. While importing a streaming context, we can define that, and that's how it will do that.
And how do we stop this?
See, there is a way by which you can await the CMS. So here you can see that. So what you have defined here, when I've defined the Spark context, this is the Spark context, right? So when I do await termination, it will wait for computation to terminate. And see, this is we have done. So now I'll show you here right now.
So Dipesh, in Databricks, how we will await termination? Because I think here in Databricks, how we will await termination, because I think we are using Spark session here. We're not initializing the Spark context.
So like in Databricks, either the one way I can use await termination also. We have not defined the Spark context here, right? Spark is
So it's the default Spark session, right? Spark context was before Spark 2.0, if I'm not wrong. So yeah.
It's a default one has been created. So I can see I can do query. We can create a sink in that case. Just a second. So here, we are reading from the direct server from this Databricks file system directly. So we are reading from read stream. So this we have to stream, read we need to stop. This we need to stop. So we can create something like this. We need to create a function. I think I need to exactly check this. So basically we can create, a transformation file where I can, whatever the input stream for wherever we are reading the data. Okay. And or where we are sending the data, like in write stream, I'm supposed to gonna send the data. So there, whatever the query that we have, the transformed when we have transformed into that write stream, right? So that file we can await. So we can await the where we are writing the data. So where it's syncing the data that we can await. So let's say while I'll show you right now. So when I will create, let's say I'm creating a query of transformation when I'll read the data into the write stream. So here when we have transformed the data, let's say we are transforming to convert as a string or counting, whatever we have defined. This, let's say here we have defined the data frame. So data frame we have created. So here, so this data frame that we have created for transformation, this I can write into my writing folder. Write stream, and this write stream, wherever the location I will be doing, this I will do this query dot await termination. Are you getting my point?
Yeah, okay.
So once
But
I
still the job will be running, right? So the write will be awaited, but the job will still be running, right? It will be looking for files
or we can do query dot stop now. That way the streaming will
that
stop.
will be stopped. Yeah, yeah.
So these two way we can do that. One is either by awaiting termination into that write folder, okay, or either I can do query, whatever the query I'm doing, query dot stop will work. Yeah. You all are done with this till here? Okay. So now what I'm going to do that is, see, quickly I will be deleting this. Okay. I will be going to delete all the files that I've defined here. Yeah. Now if you'll see here, deleted. So let's create the directory. Okay. So here now it has been created. So what I'm doing is, do you know the concept of paraquet file, all of you?
Yeah, the large file,
Yeah.
the large file format.
Yeah. So it's a kind of a large file format. And, like here, we are supposed to gonna, do one thing. So we will be going to read the data, and we will read the data and we'll try to put into this kind of a, we will proceed this data, and then once the data got read, we will put into a kind of a paraquet format. So here the directly we can proceed accordingly. So how can I write the data? So as of now, we can read the data, and how we can write the data. So for that, you know, so right now, if you see that in this, there is nothing, no data is there, right? So we will try to proceed creating this in a way So how to write, how we'll write this information here. So here I'm creating a data frame so that we will write into that writing a string. Okay. And format we are putting into paraquet, right? Good. Dot in output mode. Okay, let's append all of them. Append, and we are reading from your. We are reading this data. Let's put the path. Path is for writing is here. Yeah. So we write. Then, so once you write, we wanted to store their, like meta information and all into, into the checkpoint location and all. So here I have mounted this also. And it start. And once it's read, then I can do what you're saying. Once it starts, then later on it should await the termination. So here I can, that way once the write that I'm talking about, I can await the termination afterwards, right? So once you do this, see, like we going to be, once the data going to be read in that certain location, and here we are supposed to going to proceed the, the files over this. So let's say I have proceeded that. Option 1. Option. Value. Okay, I need to define here. It's a path, and this should be checkpoint location. So option. I'm not able to hear you, Mayur. What you're saying, something?
We have to provide the checkpoint location in the double quotes. And it should
In single quote, you're saying?
No, Deepesh, what he's saying is checkpoint location spelling is wrong. CHECK, right?
And even you can use double quote or single quote, whichever.
CCK point location here. Yeah. So here in our data right now, let's upload all the data. Okay. So here right now there is no data in the read. Okay. So it should, read all the data. Okay. So here open. Yeah. So you see that in our code, once it's reading it, let this read. Did I run this? I need to run this as well as well. Sorry. This one. Yeah. So let's see into the right table. Into the right table, let's see. Can you see that? But Spark metadata is there, right? Metadata you got. But where is when paracket checkpoints we receive? Checkpoints are created. Right. One table has been read. But it's not ready yet. Stream data not showing. Are you able to access it? Yeah, uploaded this data here. And we are streaming this. Yes. We add the data. Okay. Now we are streaming it. While I'm syncing this data right now here, not showing in my Databricks file system. Should show.
Can you run dbutils.fs command and check the page once? Because since here we are trying to select the files, we could directly see if the dbutils folder has that file or not, right?
No, it's not showing now. Here, if I am checking, I have
instead of doing from here, can you just run that dbutils.fs.ls on the path that you have created on the right and see if it is there?
fs.ls.
And give the right path.
This is the file path. No file. But we are uploading it, right? And we just now we have done it, right? These directories are already created now. I've deleted and then recreated it. The files I'm reading into the same way. Can you also try, so in stream read the data is there. And since in DF the data is here, I'm using that data frame and writing into paraquet. Okay, so let's get this. Let it all get updated. Yeah, so all the data has been read. Now let me run this. Yeah, can you see that? All the CSV files are here now. Got it? Oh, and then let me proceed to write the paraquet file. So when I write the paraquet file, Spark metadata is here. Creating the metadata. Source. But it's not created the paraquet file yet, huh? Creating, huh? We can check by printing the paraquet file. Be able to create. Here it should show some paraquet file like PART00 something like that. And write.
Only metadata file is created on the page. Try it. Same. Only metadata file is getting created.
But we are right stream we are doing now. We are creating in a right format paraquet. Appending path we have given the right. Path is also right, stream right. Checkpoint location also is right. Yeah. Where are we making mistake? Can you try this also? Like if maybe if any reason if it's not showing to me, would show you. Let me just publish it. Can you please try all of you guys? Okay. You are able to create the paraquet file?
I am creating the data file. Actually, we don't have data file, right? Can you share the data files also? That will be helpful.
You please all try, yeah. Till here it means you have not done till here also like streaming the data. Please check everyone guys. We are able to read it, completely stream the data.
Actually, Deepesh, I'm getting this error actually. It says that up and output mode not supported when there are streaming aggregations. I'm getting this error. I've just sent you the page. When I try to run that write stream, right? With the output mode, I'm able to see that error, like, up and output mode not supported. Without watermark.
The output sync is showing some problem, right? So the checkpoint you have defined over there?
Yes.
Checkpoint you have created over there?
Yeah.
Okay. Instead of append mode, can you use complete mode? Because I
Okay.
believe that I don't know like how you are accessing the data, like you have append all the data has been taken up first, or
When I try to complete, it says data source Parquet does not support complete output mode.
can you just stop, await termination where we're doing? Can you just keep that? It has to keep it doing.
I think Dipesh, data is getting writed actually. We can't see UI.
Yeah,
Can you maybe
database is
DB
not showing, but
It's
if you
not
run
showing.
the DB file utils, right, then it is showing.
Yeah.
It's
And
getting righted, but it's not showing us.
one more question I had, Deepesh. We are writing the aggregated format or the direct raw data?
Means?
I
So
mean,
can
in
you
the
see that?
above, once you read the file, right, you are doing some group by and sum of sales, and that is what we are doing, right?
Yeah,
But
I can.
down, we are directly writing the stream like df.write_stream.
Yeah, you are right.
Whatever we are reading, we are directly writing.
If
We are
we
not aggregating or something.
need to use df1 there actually,
Yeah.
the group by, and that is causing the error, I guess. Just
Because
try.
that's a aggregated. We're not aggregating here. We are using DF directly. But you
Yes.
can see that in the UI of this. See how the batch and
Yeah, Dipesh, so question is, how can we write aggregated data? Like reading the same data and writing in Parquet is fine, but can we write the aggregated data?
Instead of append, I think we have to do overwrite or something like that, if that data exists.
so the one that we have grouped by.
Yeah, that one. Can we write that data?
Yeah, I mean, but again, the aggregated data, we can write aggregated data in a structured streaming, but how we are writing, it depend on our output mode basically. So, so we need to the output type. We can type here the aggregation type. So I need to check what are the aggregation type. So we can do that in the aggregation mode. We can do that like the append mode we have taken up. We can use the aggregated mode.
How can we do that? Like, because I was getting the error, same error which Vasudev said, right? Up and output mode not supported. I also tried writing for the aggregated data and not the original data. Because original data is getting, yeah, it is getting
Use
written.
complete mode in that case because if you want to get the global aggregation, like you're using group by.
It is also showing the error actually.
Yeah, it says Parquet file format is not supported with complete output mode.
Exactly.
Yeah. So instead of Parquet, you can write into some other format.
Maybe CSV also we can try.
Right.
But
In complete mode.
same error it is happening actually. Both for append as well as complete for Parquet and CSV.
Or update, just type instead of append, just put update. Update.
Yeah. Update also is same. Maybe I will share the script there. Yeah, it is getting written right. But for only the original stream, we are actually writing in Parquet. But
Can you share your screen? Is it working in complete mode or update mode?
no, it is not working. I guess this is shared by Mayur, right? Mayur, this is the same earlier one actually.
In Parquet, I think I need to check in Parquet if the complete aggregation can happen because it's a SDFS format. And
Okay, let me share for a minute. I will show.
but why it is not showing the data bricks?
Okay, is my screen visible?
Your screen visible.
This is
Actually,
reading
like
is
when
going
we are
on.
able to write, but why is it not showing us over there in PBFS file?
Here actually it is showing when we do the ls. Okay.
Yeah, ls when we are doing it is showing.
Right. But now this is the problem.
Market file has been.
This is fine. This will work. Okay. So
CSV is working, right?
no, not CSV. I just tried various options.
Market format. So this is working.
This is working. That is fine.
You want that the DF2.
But yeah, I want DF1 basically.
DF1.
This one. Like basically this one, the group by one, which we are displaying here. I need to write that in the Parquet file. So that is
You can do that in update mode. Just write over there. Write stream where you have done dot dot output mode. Just remove the format.
the format. Remove. I should remove this.
Yeah, just output mode as update.
Right.
Okay, format on console you can type it on console. This format you can put on console dot format console.
Like this.
And you're writing into this and checkpoint. Okay.
You are saying.
Update
mode. Right?
Yeah, update mode. Yeah, try this.
This is running only.
Yeah. Now just try the output in ls. When you'll show, it will just show you that
Not getting anything. Actually, it's still hanging.
Show an output.
Mhm.
It should show an output when you do df. Just
This one here, because console I'm showing, right?
it show an output. Can you try this? This like df.
Sorry. DF with DF you are saying?
dfw is your the data, na?
This is the final one.
The final one. No. This is okay.
Shall I try append?
We can write into two steps. That's how it will be more fabricated one. So one step will be to aggregate that we have already done over there. So this when we are doing this write stream, the output mode is update. Okay. And the format instead of writing anywhere or any path or anywhere, just delete the path and all. Just see the out. In order to see the output, just delete everything here and then just we wanted to see the output.
Okay, I will delete both of this.
Delete this and just start. That's all. And even await termination if you want to. It's okay. We will.
Hi Dipesh, I think this aggregation it won't work because like we are not applying watermarking, right? It was coming mini batches. Which one to aggregate? It has to do aggregation, right? Group by aggregation. We don't know what to do. And
Instead of count,
sorry?
Group by aggregation we have done, but aggregation.
We're doing some there with respect to stock.
So it should show at least some output to us. What you're saying, Nikhil?
Yeah, it was throwing error like data frame stream writer. Okay. It requires watermarking like while applying group by or some aggregation things. But yeah, but like here when you're displaying it was printing. When we're writing it was not coming, right? So that's what I also got like thinking why it was not happening. But it should write also if we were able to.
Right. It will at least write here. Just do one thing. Just run this again because in append mode it will not work. In update mode it will only work. Just put update and just maybe.
It should at least show the output here, right? In the
Yeah, it will show the output. Into batches, batch 1, batch 2, batch 3, like that. That's how it is counting.
let me maybe upload one more file, separate file.
Oh, you have only one file here.
Oh, I uploaded already multiple times. But anyway, let me upload.
Try this. This will work. This process will work because when you want a
Now I
aggregation.
uploaded. Let's see. Now it will update here. It's running. The read is running basically. Let's see for
Do we need the display because it was single core? This is community edition, right? We
Yeah.
can't run queries. Can you stop the display command and only try write stream? At that line, you have to come in.
Correct.
And start like read stream and write stream. It shouldn't run actually anything here. It should start.
That would be one because it's just a one.
Okay, now I started. See.
Interrupt the next one also. Yeah. And rerun this one. Yeah, now it should work.
Okay, let me do one thing. I'll stop both and I'll start the reading first. I upload a file. Let's try once. Okay. So I started here.
Okay, don't let's not exaggerate it. You can do it by yourself. I told you the process. How you're gonna do that? Just I want to have a quick